Now let's consider the word problem that was given in question 3. This is a good example of a literacy style question, one in which we have to read and interpret the question to begin with, and then write our answer using correct sentence structure. It's really handy with this kind of question to grab your highlighter and make sure that you have fully read through the question and identified exactly what you're being asked to do. There are some key verbs here at the end of the question that will tell us the exact level to which we are supposed to be constructing our answer, whether or not a simple sentence is required or whether we're going to have to go a little bit deeper and show some very clear calculations to back up our response. Firstly, we'll read through the problem in full and then we'll come back and identify all the key parts. So the question says to us, Angie went to 2 department stores to buy a book worth $32. The first store offers her a discount of $5 if she pays with cash. The second store is having a 5% off everything sale. Which is the cheaper option? Justify your answer with correct calculations. So this question is asking us to compare 2 different methods of payment, determine which one we believe is the cheaper option, and then justify whichever choice we've made, showing calculations to back up our answer. If we identify the data that was given in the first part of the question, we started with a book worth $32, giving us the original price of the item. The first store is offering a cash discount of $5, meaning that we are simply required to take the original value of the item and subtract off the discount. The second store is having a 5% off everything sale, meaning that every item in the store has been reduced by 5% of its original cost. So this calculation involves us taking 5% of $32 off the original cost of the item. We know that we can do this very quickly by multiplying the original cost of the item by the percentage that we would have left. So if we were taking 5% off, we would have 95% of the original cost of the item. The question is asking us to compare these 2 calculations. So by working it out, we will be able to correctly justify which of those options is the cheaper one. So let's set up our solution. Option 1 asked us to take the original cost of the item and subtract the discount from it. So remembering the data that we had above, the original cost of the item was $32 and the discount was $5, giving us a total for option 1 of $27 as the final sale price. Option 2 asked us to multiply the original cost of the item by 95% to work out the new sale price. So the original cost of the item being $32, 32 times 95% or 0.95 as a decimal gives us a new sale price of $30.40. Since we are being asked to justify our response, we need to now set up a correct sentence that links back to the maths that we've just calculated. So we can very clearly see that option 1 is the cheaper option. And so we will start our answer ensuring that we use correct punctuation by stating that option 1 is therefore the cheaper option as subtracting $5 from the original amount gave a lower sale price than decreasing the $32 by 5%, making sure we finish with a full stop. Thinking back to exactly what the question asked us to do, we have very clearly justified why we chose option 1, and we have linked back to the calculations that we were required to write down. Question 4 was another algebraic question, this time asking us to consider our multiplication and division laws. As we have seen before, we can actually start to cancel like terms in a division before we even do the multiplication on the top, if we can see them to begin with. So having a look at what is on the bottom of our fraction here, we have an A term and there are 2 of them sitting up the top, meaning that we can cancel one A from both the denominator and the numerator. There's also a B and 3 B's, 1 here and 2 here, sitting up the top. So cancelling a B from each, we would be left with 2 B's sitting in the top and none left in the bottom. And finally, there is a C term and a C term sitting on the top, meaning that the C's will completely cancel. We can also consider the numbers here, but you can plug that part into your calculator as well just to double check. I do know that 3 goes into 6 2 times. So if I divide both the top and the bottom by 3, the 3 at the top will cancel to leave me with 1, and the 6 down the bottom will cancel down to leave me with 2. Once I have cancelled as much as I can now go ahead and complete my answer by fixing up the top and collecting all the terms, leaving me with a 7, 1A, 2 B's and no C's remaining, and on the bottom I'll be left with just a 2 as everything else has cancelled. The final question was asking us to look at converting units of area. The first question was a straightforward length conversion, asking us to take 0.2 kilometres and convert it into centimetres, which means we're going to have to do a double conversion. First, we need to multiply that 0.2 by 1,000 to take it from kilometres into metres, knowing that there are 1,000 metres in a kilometre. But we didn't need metres, we needed to go further than that and take it all the way down to centimetres. Since there are 100 centimetres in a metre, once we multiply by 1,000 to take it to metres, we then need to multiply it by 100 to take it down to the centimetres that we're looking for. This will move that decimal point 1, 2, 3, 4, 5 decimal places to the right, making the number bigger, giving us an answer of 200,000 centimetres. The following questions are all conversions for area. And as we said before, we can work out our area conversions if we know our normal length conversions by squaring all of the conversion rates. So looking at what we're required to change here, we need to take square metres down to centimetres. We know that there are normally 100 centimetres in a metre, and if we need to square those to get our area conversions, we square everything. So we square the 100, square the centimetres, square the 1, and square the metres to get the units we require. So 100 squared gives me back 10,000 square centimetres, and 1 squared is just 1 square metre. giving us the conversion we need. So we need to multiply that 4 by 10,000 to get the square centimetres required, giving us 40,000 as our answer. The next question is exactly the same idea. This time we're taking square metres up to the larger unit of square kilometres. Normally there is 1,000 metres in 1 kilometre, but we want square units, and so we're going to square our conversion rate. So 1,000 squared gives us 1,000,000 square metres in 1 square kilometre. This time, however, we're taking our value up to a larger unit. And so the value itself, that number that we see there, is actually going to get smaller. So with this time, we need to divide the 0.02 by 1,000,000, giving us a very tiny number. It's going to move that decimal point 6 places to the left, giving us 0 point, and we'll need 6 extra zeros before we put in the 0.2 that was already a part of our decimal. The last conversion is the one I told you that you had to remember. So looking at what we have, we want to take 3.5 hectares to square metres, and the conversion I gave you was that in 1 hectare there is always 10,000 square metres. So we need to multiply 3.5 by 10,000, as the square metres is the smaller unit and it should have a larger number next to it. So multiplying 3.5 by 10,000 gives us 35,000 square metres. And that finishes off the revision questions that I needed you to complete.